So here are the notes for section 5.5, which is the law of sines. So the law of sines states that if you have any triangle ABC with angles A, B, and C and opposite sides little a, little b, little c, so side A is opposite angle A, the following equation is true. So sine A over A equals sine B over B equals sine C over C. Now we will only ever use two parts at a time, so you don't use the full three. You'll have one fraction that you know both values for, and one fraction that you know one of the two values for, and use it to find the remaining value. The following equation is true. Now, the one thing that we have to be careful about with law of sines is that, we'll see it in example 2, you may have more than one possible solution. And that typically depends if you're given two sides and one angle, you do have to be careful about that. So, solving the triangles. So we're going to use this setup. So solve ABC, given that angle A is 36, angle B is 48, and side A is 8. So we'll just jot down our, so A, solving the triangle, once again, means finding all your values. So we'll just write, there's our 6 values, so I can fill some of them in. I know angle A is 36 degrees, angle B is 48 degrees, and side A is 8 degrees, or sorry, just 8. So in this case, where I have two sides and one angle, I can actually find, or sorry, two angles and one side. The first thing I can do is actually find the third angle. Now, it doesn't matter which of the two I'm given, I can always find the third one because I know that all three angles in a triangle add up to 180. So angle C here is going to be equal to whatever 180 minus 36 minus 48 is. It only has one possible value. So I'm handing in the calculator. It tells me that 180 minus 36 minus 48. So angle C has to be 96 degrees because it's the only possible angle allowed. Now, to find side B and side C, we're going to go back up to these fractions. Now, these fractions are true, but if I'm solving for sides, I actually want to flip all the fractions over so the sides are on top just to make the math a little bit easier for myself. So I have to use the A fraction because I know both values for A. I'm going to run it once with the B fraction to find little b, and then repeat the process with the C fraction to find little c. So for example, to find little b, we're going to do A over sine A equals B, which I don't know, over the sine of B. So if you look at how this problem sets up, doing the algebra is relatively straightforward. Make sure my calculator's in degrees. Divide by this, multiply by that. So I'm actually going to type it in all at once. I'm not going to find decimal values for those first because the less times you round, the better. So 8 divided by the sine of 36. We'll simplify this side. And then multiply by this to get it out from underneath the b. So times the sine of 48. So little b is, we'll call it 10.11. We'll fill my little chart in over here, 10.11. Then I repeat the process for C. So 8 over sine 36 is equal to little c over sine 96. Now notice that I used A again here. Technically, I could have used B because I know now the value for little b, so I could have done little b over sine big B equals little c over sine big C, but that's a rounded value. So I want to use the problems given to me, or the numbers given to me in the problem. So 8 divided by the sine of 36, it's the same number it was before, but now it's times sine 96 to get that out from the bottom. So little c is equal to 13.54. And I have solved my triangle. All three angles, all three sides. Now the problem with law of sines is that you can have what's referred to as the ambiguous case, and that's if you have two sides and one angle. If you have two angles, if you know two angles, there's only one possible triangle because the third angle only has one possible value. But if you have two sides and one angle, you have to potentially have two triangles. So angle A, angle B, angle C, little a, little b, little c. So that's triangle 1, and we have to repeat the process. Now, we might not actually get any triangles over here, but we have to be prepared if you have two sides and one angle. Now, both of them start the same way. So 7, 6, and this is 26.3 degrees. And over here, also 7, 6, and 26.3 degrees. Now, if you notice, we can't do our angle trick because we don't know enough of them. We can't subtract from 180 and divide by 2 because we don't know that these are isosceles triangles. However, I can find angle B because I know both values of A and one of the values of B. So since I'm solving for B, the angles are going to go on top. So sine 26.3 over A, 7, equals the sine of B over 6. So sine A over A equals sine B over B. Now I can do the math kind of the same way I did before. The sine of 26.3 divided by 7 times 6. I get this decimal number. But that's not my angle B. When I do that, that's what sine B is equal to. 6, I'm going to write this version. So multiply 6 across. So what I actually need to do is take the inverse sine of this decimal number. So the angle is actually 22.32 degrees, or we'll call it 22.3 since we have a tenths place here. So 22.3. Now the thing you have over here, to get this second triangle, these two angle B's have to be supplementary. They have to add to 180 because that will happen in the ambiguous case. So to find this angle B, I take 180 minus this value. So 180 minus 22.3. So if there are two triangles, that one has an angle of 157.7 degrees. So let's see here. What do we get? So now I can find angle C in both cases. Now once you've done that step, these two triangles run entirely separately. So over here, to get angle C, I would do 180 minus 26.3 minus 22.3. 26.3 minus 22.3. So this is 131.4 degrees. Over here, same thing. Angle C is going to be 180 minus 26.3 minus 157.7. If I do that, 180 minus 26.3 minus 157.7, I get angle C is equal to -4. That's impossible. This triangle cannot exist. These two angles already add up to more than 180, which means I don't have a triangle. So there is not a second possible triangle here. So over here, I just come back and finish out little c. So to do that, since I'm looking for sides, I'm going to go back to putting the sides on top. I am going to use my a fraction, so 7 over sine 26.3 equals little c over sine 131.4. And then in the interest of space on my paper, 7 divided by the sine of 26.3 times the sine of 131.4 gives me 11.9, we'll call it, since we're rounded to the 10th place everywhere else. So those are my solved triangles. This one can't, essentially what happens is this one doesn't close. The angles are too wide. So, you know, you have something that like this where, you know, if you could extend that, you could, but the angle's too big. It doesn't let the triangle close down on itself. Okay, so let's look at example 3. So same setups. So we're given two sides, so we have to assume that we may have two triangles. So for the first triangle, angle A, angle B, angle C, side A, side B, side C, angle A, angle B, angle C, side A, side B, side C. So remember, they start the same. So 6 and 7, 6 and 7, angle A is 30 degrees, angle A is 30 degrees. So over here, we're going to find B first. So angle's on top, since I'm solving an angle. So sine 30 over 6, A over A, sine B over 7. So the sine of B is going to equal the sine of 30 divided by 6 times 7. 0.583 repeating. But then I need to take the inverse sine to get the angle. So angle B is 35 we'll call it 7 degrees. Now remember, this angle B is supplementary. It has to add to 180. So to get this angle B, I take 180 minus 35.7. So if there is a second triangle, this angle B is 143 degrees. So over here, I can find C. So angle C equals 180 minus 30 minus 35.7. So angle C is 114.3 in this triangle. Over here, I can do the same thing. C equals 180 minus 30 minus 144.3. So over here, angle C is 5.7. So this is a valid triangle. So now I have to find the little c's in both cases. So I'll actually do this one because I'm already on this side. So little a over sine big A equals little c over sine big C. So 6 divided by the sine of 30 multiplied by the sine of 5.7, and little c comes out to be 1.2. Over here, 6 over the sine of 30 equals c over the sine of 114.3. So 6 divided by sine 30 times sine 114.3. Little c is 10.9. There's kind of a really quick way to check to see if your answer is at least reasonable. Is in a triangle, the sides and angles are proportional. So the largest angle should always be across from the largest side. So there's the biggest angle, there's the biggest side, so they're paired off, and the smallest angle should be with the smallest side, smallest angle, smallest side. So over here, biggest angle, biggest side, smallest angle, smallest side. All right, some applications. So Forest Ranger Chris Johns is at Ranger Ranger A, sights a fire in the direction 32 degrees east of north. Ranger Rick Thorpe at B, 10 miles east of A. So here we'll draw a picture. There's A, there's B. You know, this distance is 10 miles. Sights west of north. So remember, when you're measuring directions, you're measuring off of north. So this person east of north. This person's looking west of north, so the fire is up here, essentially at point C on the triangle. Now the thing is, 32 degrees east of north, that's this much. So to find the angle actually inside the triangle, I need to do 90 minus 32. So this angle here is 58 degrees. Same thing over here. 48 degrees west of north, this much is 48 degrees. So inside the triangle is 90 minus 48. So this is 42 degrees. Find the distance from each, that should be range or station. So if I look at my triangle, this side down here across from big C is little c. So over here, this is A, this is B. So from Chris's site, I'm finding angle measure B, and from Rick, it's A. So we just essentially are solving our triangle. So fill in your values, A, B, and C, little a, little b, little c, and we'll solve the triangle. So let's see here. Angle A is 58 degrees. Angle B is 42 degrees. Angle C is unknown. Little a is unknown, little b is unknown, and side C is 10. Now, it does not look like I can do this because I don't have a pair, but remember, since I know two of the angles, I can figure out what big C is. 180 minus 58 minus 42. So this angle is 80 degrees. And now I have a pair. So to find the distance for Chris, that means I need to find the value for B. So 10 over sine 80 equals B over sine 42. So B is equal to 10 divided by sine 80 times, whoops, didn't hit the divide, 10 divided by sine 80 times sine 42. So it's about 6.8 miles from Chris. For Rick, that's side A, so 10 over C over sine C equals A over sine A. So 10 divided by the sine of 80 times the sine of 58. So from Rick, little a is about 8.6 miles. So that tells you where they are. Okay, so example 5, road slopes 10 degrees below horizontal and vertical telephone pole stands beside the road. The angle of elevation to the sun is 62 degrees and the pole casts a 14.5-foot shadow downhill along the road. Find the height of the telephone pole. So let's see what we can do here. So So there's my telephone pole. The road is at an angle, so I need to close that to get my triangle. So I know this side is 14.5. I know that this angle down here is 10 degrees. So if the angle of elevation to the sun is 62, that's measured from the horizontal. So this angle here is 62 degrees minus the 10, which is 52. So inside the triangle here is 52 degrees. Let's see here. What else do we know? Oh, this angle here, if I had dropped it down, would have been a right angle, but it's 10 degrees more because it's lifted up. So this angle here is 100 degrees, which means I can find this angle here by doing 180 minus 52 minus 100. So this angle is 28. So now I'm going to drop angles in. So we'll call this angle A. That's corner A. This will be B. This will be C. So I'm actually looking for little a. And I know this 14.5 is little c, which is across from angle C. So if I do my triangle, angle A, angle B, angle C, angle A is 52, angle B is 100, angle C is 28. Little a, little b, little c, I know little c is 14.5. Now, little b is actually over here. It's the distance from where you are to the top of the pole, but I don't care about that distance. So I'm not actually going to worry about finding b. I just need to find a in this case. So little c over sine big C equals little a over sine of big A. So little a is equal to 14.5 divided by the sine of 28 times the sine of 52. So 24.3 feet tall-ish. And that, I believe, is the end of the section.